The James Webb Space Telescope has given us the clearest view yet of Proxima Centauri and its intriguing planet, Proxima B. It's an exciting development because Proxima B is located in a zone where life could possibly exist outside our solar system. Let's dive into what makes this nearby exoplanet so fascinating and whether it could be anything like Earth. Proxima B orbits the red dwarf star Proxima Centauri, just 4.2 light-years away, our closest stellar neighbor. It's situated in the so-called habitable zone, where temperatures might allow liquid water to exist. If a planet has water, it could potentially support life. But it's not the only planet in the system. There's also Proxima C, farther out, and signs hint at a third planet, possibly Proxima D, about the size of Mercury or Mars. Proxima Centauri emits about the same amount of energy to Proxima B as the Sun does to Earth, which sounds promising. However, the reality is more complicated. A year on Proxima B is just 112 Earth days. It orbits much closer to its star than Earth does to the Sun, meaning one side of the planet is likely locked in constant daylight while the other remains in darkness, a condition called tidal locking. Proxima Centauri itself is part of a triple star system known as Alpha Centauri, which includes Alpha Centauri A and B. These two stars are bright and visible in the night sky, often appearing as one, while Proxima Centauri, also called Alpha Centauri C, is a faint red dwarf farther out. You can't see it without a telescope, but it's closer to us than any other star. Red dwarf stars like Proxima Centauri burn fuel slowly and can shine for trillions of years. Proxima has around 4 trillion more years of life left. But these stars come with a catch. They're prone to flare-ups, emitting bursts of radiation that can strip away a planet's atmosphere. And because their habitable zones are so close, orbiting planets like Proxima B are exposed to intense ultraviolet radiation. This makes it tricky. Even though Proxima B lies at the right distance from its star, it may not have a stable atmosphere, which is crucial for maintaining surface temperatures and liquid water. Without an atmosphere, life, at least as we know it, would struggle to survive. Despite these challenges, astronomers remain hopeful. The James Webb Space Telescope, launched in 2018, is one of our best tools to study distant worlds. It specializes in observing infrared light, which can reveal the presence of water vapor, carbon dioxide, or even patterns that hint at an atmosphere. If Proxima B reflects or emits certain wavelengths of infrared light, JWST might detect them. Physicist Abby Tabor explains that if Proxima B can absorb and emit infrared light from its star, we might spot clues about its atmospheric makeup. But as astrophysicist Ed Turner points out, having an atmosphere doesn't mean there's life. Venus, for example, has a thick atmosphere but is scorching and uninhabitable. Proxima B might be similar, a hot, toxic world despite being in the habitable zone. Proxima B is classified as a super-Earth, meaning it's larger than Earth but smaller than Neptune. That size makes it especially interesting to scientists, as it may have solid ground and conditions at least somewhat similar to our own planet. It's close enough that one day, we might even send a probe there. But current spacecraft like Voyager 2 would take over 75,000 years to make the trip. That's why researchers are exploring new methods of interstellar travel. One idea is to use solar sails, ultra-thin, reflective sheets that ride on light pressure from the sun. These could propel tiny spacecraft to nearby stars without traditional fuel. If this technology works, we could one day launch missions to Proxima B and other nearby exoplanets. The hunt for exoplanets, planets beyond our solar system, is in full swing. So far, we've discovered over 4,000 of them. Some orbit Sun-like stars, others drift through space without a star at all. We've found gas giants like hot Jupiters, which orbit close to their stars and are extremely hot, and super Jupiters, which are even larger. There are also Neptune-like exoplanets, some hot and some cold, and of course, the Earth-sized rocky planets like Proxima B. One of the main ways we detect exoplanets is through the transit method. Telescopes like Kepler watch for small dips in a star's brightness when a planet crosses in front of it. This helps determine the planet's size, orbit, and sometimes temperature. Other methods measure a star's wobble caused by a planet's gravity or capture direct images if the planet is large and far from its star. Exomoons, moons orbiting exoplanets, are another area of growing interest. Some could potentially host life themselves. TRAPPIST-1, for example, has 7 rocky exoplanets, several of which lie in the habitable zone and may contain water. NASA's James Webb Space Telescope has already found carbon dioxide in the atmosphere of a planet beyond our solar system. This marks a major step forward in understanding how these worlds form and what they're made of. The telescope also studies dusty disks where planets are born and helps us understand the chemistry of ices and atmospheres around other stars. Although Proxima B faces many challenges, it's still one of the most promising candidates for life beyond Earth simply because it's so close and Earth-sized. While it may not be hospitable, the fact that it's right next door gives scientists an incredible opportunity to study a potentially Earth-like planet in detail. We're still far from confirming life on Proxima B, or any exoplanet, but every piece of data brings us closer. And as technology improves, the day may come when we spot the unmistakable signature of life elsewhere in the cosmos. For now, Proxima B remains a tantalizing mystery, a nearby world that just might hold the key to answering one of humanity's oldest questions. Are we alone?